हेलो एवरीवन एंड वेलकम टू दिस चैनल। तो आज हम लोग करने वाले हैं एनालॉग इलेक्ट्रॉनिक्स 1 में हमारा अगला टॉपिक दैट इज स्टेबिलिटी फैक्टर फॉर वोल्टेज डिवाइडर बायस। सो हियर वी हैव अ सर्किट दैट इज ऑफ वोल्टेज डिवाइडर बायस एंड वी नो दैट टू सॉल्व दिस वी विल हैव टू यूज अ थेवेनिन थ्योरम। अब थेवेनिन थ्योरम में वी हैव our two main parameters. The first one is Thevenin voltage and the second one is Thevenin resistance. Now we have already seen in our previous videos that in case of voltage divider bias, our VTH is going to be equal to R2 times VCC by R1 plus R2 and RTH is going to be equal to R1 R2 by R1 plus R2 and इस सर्किट को हम लोग इस तरीके से रिप्रेजेंट कर सकते हैं। Now there is an important point that is stability factor does not depend on VCC, so replacing VCC with VTH will have no effect. अब stability factor निकालने के लिए we are going to follow the same three steps as we have seen in our previous videos. The first step is to calculate the value of IB. The second step is to put the value of IB in this particular equation, that is IC is equal to beta times IB plus beta plus 1 times ICBO. And the third step is differentiate with respect to IC, keeping beta and VB as constant. अब यहाँ पे अगर हम लोग वोल्टेज डिवाइडर सर्किट को हमारे एमिटर बायस सर्किट से कंपेयर करें, so we know that in emitter bias our stability factor is equal to beta plus 1 times RB plus RE by RB plus beta plus 1 times RE. अब इसी चीज को if we have to get the value in voltage divider bias, so after calculating you will just see that we just need to replace our RB with RTH. So we are going to have our stability factor as beta plus 1 times RTH plus RE by RTH plus beta plus 1 times RE. And यही सेम चीज हमारे S प्राइम में भी होगी, which is going to be equal to minus beta by RTH plus beta plus 1 times RE. Now let us talk about what do we mean by transistor saturation. So उसकी condition होती है which is IC max should be less than equal to IC saturation. Now in case of transistor we know that अगर हम चाहते हैं that it should work as an amplifier, so our transistor should operate in an active region. And for active region we know that our common base junction should be in reverse bias and our emitter base junction should be in forward bias. But in case of saturation region we know that कि हमें हमारा common base को forward bias करना होगा and emitter base junction हमारा already forward bias होगा, due to which our resistance get approximately equal to 0. So here we have our output characteristics for our common emitter configuration and we already know that this particular region is known as the active region, this is our saturation region and this is the cutoff region. अब क्योंकि हम लोग बात कर रहे हैं about the saturation region, so हमारा Q पॉइंट भी इस पर्टिकुलर रीजन में ही लाए करेगा। अब इस पर्टिकुलर कर्व को अगर हम लोग थोड़ा सिंप्लीफाई कर दें, so it is going to look like this and here we can see that कि जैसे जैसे हमारा IC इन saturation region बढ़ रहा है, our VC is equal to 0 volt. अब यहाँ पे अगर हम लोग Ohm's law अप्लाई करें, so we know that IC sat multiplied by RC is going to be equal to VC. Now we know that VC is equal to 0, so यहाँ से हम लोग देख सकते हैं that RC is going to be equal to 0 ohms. इसका मतलब यही है that our common and emitter ends are going to be short circuited. अब बात करें हम लोग the saturation condition for the fixed bias configuration, so उसके लिए we just have to apply KVL in the output loop of the circuit after short circuiting the common and emitter ends. So we are going to get our equation as VCC minus IC saturation RC equal to 0. तो यहां से we are going to get the condition which is equal to VCC by RC. Similarly हम लोग हमारी condition for emitter bias में निकाल सकते हैं and we are going to follow the same process. We just have to apply KVL in the output part of the circuit. So we are going to get the equation as VCC minus IC sat RC minus IERE is equal to 0. Now we know that IE is approximately equal to IC and यहाँ पे हम लोग IC को लिख सकते हैं by IC in saturation mode. So we are going to get an equation as VCC minus IC sat times RC plus RE is equal to 0 and our condition is going to be equal to VCC by RC plus RE. So that was all for this video and I will see you in the next one.